Video number 66 plus. The word universe is a nonsense. Hello. In video number 3 plus, I say that this word has no meaning, and today I will clarify what I mean by that. The first thing is that in science, when a word is used, it must mean the same thing for everyone. Ambiguous terms remove all value from the discourse that contains them. The concept of the universe seems to be close to that of the cosmos, invented at an ancient time where not much was known about our environment. But it is supposed to represent something much more extensive than the naive presentation that people had of it in antiquity. In the dictionaries, it's usually written, the set of everything that exists, specifying that in astrophysics the term takes a capital letter. In the English version of Wikipedia, the definition has now become more precise. The universe comprises all of existence, all forms of matter and energy, and the structures they form, from subatomic particles to entire galactic filaments. But this definition subjects the concept of the universe to its most recent representation, and it is a bad idea to subject our definition to any current or even future set of physical theories. In video number 3 plus, I cited Cantor Theorem to justify my doubts about the relevance of the concept of universe. I will now elaborate a bit more on the content of this theorem and how it is related to the question of whether the universe is logically definable. Mathematicians manipulate objects of various natures to which they apply calculations and logical reasoning. Elementary objects such as numbers, geometric points, and more complicated ones such as vectors, matrices, operators, etc. These objects, for the convenience of reasoning, are arranged in collections or boxes called sets. The fact of organizing objects into mathematical sets avoids the complicated question of their nature. It is the set to which the object belongs that somehow defines its nature. And in reasoning, we only associate objects of the same nature. The set constructed from objects are themselves mathematical objects, but these objects are a different nature from that of the elements of the set. For example, a set of numbers is not a number. Even when the set is reduced to a single element, we denote differently the number x and the set whose only element is x, conventionally noted as x between braces. To be able to associate objects in mathematical calculations or reasoning, we force them to fit into the same box. An example of such a box is the set of integers between 0 and 9, which correspond to our decimal digits. Another example, this one, infinite, is the set of all integers. As you can see, some boxes contain others which are smaller. This is what we call subsets. For example, the set of even integers is an infinite subset of the set of integers. The larger the box, the more we can afford to associate very different objects in reasoning. That's why it was legitimate, when the mathematical theory of sets began to be rigorously developed, to wonder if there might exist a set which contains all the others. The answer to this question could have been guessed because, if a set contains all others, it must in particular contain the set of all its subsets, called the power set, which contains itself as an element. It could therefore be an element of itself, but a set and its element are not of the same nature. Moreover, if that were the case, the construction of sets would not allow for a natural classification of things. In 1891, Georg Cantor demonstrated that there is no universal superset, meaning that in mathematics there is no universe. He deduced this from the fact that the power set of any set is strictly larger in a very precise sense than the starting set. For a finite set, it is obvious, because a set with n elements has 2 to the power n subsets, and 2 power n is greater than n. Cantor obtained the equivalent result for infinite sets, and the result followed. Let's return to our universe. It is supposed to be the set of everything that exists. At the semantic level, it is exactly the mathematical notion of a universe, which therefore should not exist, according to Cantor. But actually, we must think more carefully. The problem is not with the set, but with its elements. The issue is the notion of existence itself. What meaning should we give to that? Should we deny the existence of objects that we cannot detect? And what about those that will never be detectable before the disappearance of our species? Do we declare their non-existence even though they may have an effect on us without our knowledge? From this point of view, the very notion of existence is nonsensical. Basically, the universe, as conceived today, contains 3 ingredients: vacuum, matter, and electromagnetic waves. Until Torricelli, the existence of a vacuum was unknown. Radio waves were discovered not so long ago. We know today that the void is crossed by particles that are neither material nor waves, like neutrinos. Who can tell us that in 1,000 years we will not have discovered other completely new ingredients? Who can be certain that we will ever know the entire list? If, for example, it is infinite, it will never happen. And this cannot be excluded by any purely logical argument. Well, at this point, I just hope that I haven't given you too much of a headache. But perhaps you are beginning to understand why I describe the notion of the universe as a megalomaniac fantasy. Now, one thing is certain. We do not need the logically self-contradictory abstract object named universe to understand the world around us and use its resources to improve the lives of our fellow beings, which is still the primordial goal of all science. Perhaps in the future, within the framework of increasingly precise science, we'll be led to define relevant notions of the universe well suited to allow astrophysics calculations. But closing the situation by betting on the non-existence of what we still do not know will never be a valid scientific attitude, as the evolution of knowledge since the dawn of science has shown that it is always wrong.